To be a physicist and say shut up and calculate is to say you don't understand physics. The math is a way to prove observation and experience. If you cannot tie your theory to the world, it is probably wrong. If you need to add terms and ignore others, it is probably wrong. To say the universe doesn't know what a result is before it's measured is to say the Earth is the center of the solar system all over again. We do not matter. The result is independent of us. Our measurement alters it in a predictable manner. We just can't see the fine details. Looking at a blurry black and white image and saying it's a black dot is correct, but if you focused in, you could see a globe. You could see that it is a globe. And if you zoom in more, you can notice geological features. Then you realize the image should be colored. This is what we are missing. The blurry black dot is what we are using, right? So from our perspectives, calling it a blurry black dot for this description that I created, if we don't have it focused, so we look at it and we say, oh, that's a blurry black dot. That's correct. That's not a wrong answer, and it works, right? But if you focus it, then you realize, oh, it's not a black dot. Oh, that's a globe, right? That's a planet. And then you go, oh, well, it's not just a planet. We can actually see, geological features, like there's mountains and, oceans and stuff on this planet, and then you realize, well, actually, maybe this image should actually have color and it shouldn't be black and white. So then, there's another layer to it. And so it goes from being this blurry black dot, right, to a colorful image of our planet. And that's just kind of my sort of analogy I tried to write up here to explain that there is so much that we could be missing because we have approximated things and we say it's this because of this without really digging deeper into the details and the finer patterns of the universe and giving a true explanation of why there's so much that we are ignoring. Because it works, right? And it works until it doesn't work, right? And then we go, I don't know why it doesn't work. It works for all of these things. And it's because we're using approximations. But when you're trying to find out something with a long string of significant digits, but you were using only one digit for your calculations, obviously you're going to start getting very wrong results when you try and, use those significant figures. Like, you can't just bring them back in after ignoring them, right? Once you ignore them, they're gone. You lost that data. That information is no longer there because you cut it out. So obviously when you go back to look at these fine details and get a more accurate result, it's not going to work because your process wasn't made for getting that result. And basically, that's the bare bones of it. And I feel like I'm sounding like a broken record here, but the point I'm trying to get across is that our physics is not done. And it's pretty flawed. And I feel like it's almost weird. I mean, I imagine that every point in time, people felt the same way, that physics was almost figured out and everything that could be discovered was. So it feels like at this point, right? At this point, we should know everything. But, there's really no concept for what everything is, right? So we don't know what we don't know. And so to think, oh, we know everything is kind of ridiculous. To think that we have all the answers and will ever have all the answers is kind of ridiculous, right? because we don't know what we don't know. But it is a weird feeling to feel like, you know, we really don't understand anything. We have like some approximations made up, and you know the math checks out, but that's about as far as it's going right now. Like everything is just guesswork on the theory side of things. On the math side of things, it's working. It's great. But on the theory side, you know, we're throwing darts at the wall. We got no clue what's going on. We have no good reasoning for why. And I think that that's kind of crazy. And maybe that's just me, but you know, I thought that we had for a long time. You know, I just relatively recently really took a deep dive into physics because I found out what relativity and gravity really was and how it was described, and I was like, wait a minute, that's what we think? I guess I just never really thought about it. Right? And the problem is that I think that's the case for most people. No one really thinks about it. It's like, well, someone else, you know, figured it out. It's probably right. Everything's good. And that's not always the case. And so I started thinking about it, and I started looking at it, and I'm like, wait a minute, what's going on here? This isn't right. And you know, maybe I'm totally losing it, and I don't know what I'm talking about. But I've either completely gaslighted myself into believing I'm correct, or I am, right? So I'm going to just keep talking about it. I'm going to do my best. I'm going to try and actually write a paper, which, you know, I've never really done like a paper to a journal. Like if it actually got published and people were like, oh, you're right. I don't even know how I would feel, because something on that scale, it's like, no one thinks that that's gonna actually happen to them. Like no one wakes up and says, you know what, I'm gonna be the next Einstein or something like that. Like, so for people to look at my stuff, the whole world to look at what I am basically proposing and say, you know what, you're right, would be crazy, because I'm basically going against a lot of what we believe right now. And so for everyone to do a 180 or, you know, maybe a 45 degree turn would be pretty crazy. You know, and I'm just going to keep doing this until I decide I've done enough, and maybe I realize it's not worth my time. I don't know. We'll see. But, yeah, I don't know. Peace out.